Welcome, everybody. Thank you very much for listening in. It's Brendan and Hayden together today in the Nevin office of Markham, and we're going to be talking about admixtures in the concrete industry. And we're getting a lot of feedback at the moment on the industry seeking to use less cement in view of lowering its carbon footprint. And we'd like to have a little bit of a talk about that and the impact of what that has to do on your mixes and how it can be helped. Thanks for joining us, Hayden. And can you tell us a little bit about yourself and your place in the industry and your experience in the admixture space?
Cheers, Bruno. Yep, it's good to be on another session, and a very good session around admixtures, around concrete production. So yeah, I've been with Markham for circa 10 years, and come through the concrete construction space. So I've good experience through various levels of concrete, from production to placing to existing. But we're just seeing this major move, aren't we, Brendan, around the drive to reduce cement in concrete and look at cement replacements, these SCMs, these calcined clays, a lot of different pozzolans, etc., to help concrete on its journey to become more sustainable. But alongside that, I think what we're seeing, and where the industry needs to get our heads together more, is that can have effect on, obviously, workability of a mix. Some of, good old GP mixes, etc., very easy to work with. That's the same consistent result. But, so that can result in, obviously, pumping, placing, finishing type issues, and that can obviously ultimately affect our durability, starting with the workability. We're not getting the concrete into the right place as easy as we did. We're not finishing it as easy as we did. And we can get the concrete, it can be a little bit detrimental to long-term effects, durability of the surface, what's happening over the long term, and those sort of discussions start coming in. But I suppose that's why we are focused on making concrete better, as in making it the best it can be. 100% back the drive for reduction of cement, and looking at some of these SCMs. But now, how can we make that concrete the best it possibly can be, do you think?
Yeah, that's good and sympathetic, but it's a big change in the industry. It's come in a fairly short time frame, really, or it's coming. And there's folks out there who've been in the industry for a very long time, a lot of experience with concrete as they know it, and this is having some impact on that. So what's being seen in the lab isn't necessarily what's being experienced on site. So it's a learning curve across the board, I would say, if that's fair.
Yeah, 100%. And that's exactly right. What you see in the lab to what you see in the field is often quite different. You get very consistent results in a lab. You're working with exactly the same materials. They're exactly the same procedures, etc. But then you start going through some variances, even weather, you know what I mean, hot, dry versus wet, cold, what's your sand, what's your processes, and then you get these mobile plants, etc. There's so many different variables, but there is a way to work to get it the best it can be. And what I do like about the industry at the moment is there is a preparedness to try. There is some awareness. There is awareness that we need to keep improving, and I think that's good. There's a lot of ready-mix companies, etc. Production teams now have like innovation managers, and they're brought on to look for the best ways to do things. So I think it's really good.
So you talked about workability. You brought that in fairly early on what you're saying. Can you tell us more about why that's important and what the effect is on the concrete's durability?
Yeah, that's good. I mean, workability is essentially getting the concrete in its form to where it needs to be, in the right quality, to be the best for that structure. And a lot of these, because we're putting new materials, etc., into concrete to beat the sustainable game, that does have effect on workability. Things are harder to pump, harder to line pump or up multi levels or underground for a long distance. Are we still getting the same concrete that comes out of the batching plant into the pile holes, so to speak, or into the big mass pours? And workability has a large effect, I believe, and very important on long-term durability. So if your workability's out, it means it's a lot harder to get into the right spot. You might get congestion around steel, you might get segregation, as your rheology, as it helping you place and finish to get that right result. Obviously, it gets into cracking. Those sort of things can come in if we're not working it properly, and that obviously allows over time moisture ingress, etc., and premature deterioration. So it really starts from having a good workable concrete that you can you set your quality levels by. So I think it is important. Ultimately, workability, I believe, workability and durability go pretty much hand in hand.
Yeah, it's good. The need to make sure that what has been planned, say back at the mixed design stage or whatever, is what's actually landing in the slab or in the pile or in the unusual shapes in some cases.
Yeah.
Yes, places where workability can be a challenge.
Absolutely. I mean, you take sprayed concrete, you take undercarriage construction, you take these massive mass pours where you've got a big depth of concrete. There's a lot of steel in all things concrete now. So you get congested, you get voids forming, and it's all really the effects of workability. And there's a lot of different ways of measuring that, etc. But if you're getting segregation, if you're getting delays, it does ultimately affect strength, and then ultimately affects your durability of your structure.
Very good. Or very bad, as the case may be.
It is. It is.
Just jumping sideways a little bit, Markham, if we may refer to what the work we've done and the research we've done in this space, and it's been working with effective colloidal silicas on concrete workability in admixtures. And before we dive too deeply into that, can you tell us a bit about what a colloidal silica is in the context of concrete and what it does to the concrete?
Yeah, no, that's good. Well, I mean, Markham's worked with colloidal silica for concrete for about 30 years now. A lot of track record in both inclusion, as in admixtures, and spray applied treatments. But essentially, it's a very, very small silica particle, nanosilica. I mean, it's we're talking a particle size less than 100 nanometers. Very, very small particle, even comparison to the width of the hair of your head. It's only a very small percentage of that. And what it essentially is, but it's that silica particle, and it's suspended, it's stabilized, but suspended in liquid form. So, that's where the colloidal comes in. But it's essentially used as a tool to maximize cement hydration through that process. But then it over time, you're actually growing more calcium silicate hydrate with it. And it becomes more density within the concrete and helping that concrete hydrate, be dense, and be the best it can be. So it's been around for a long, long time. It can actually date back. There's research out there that dates it right back to sort of Roman times, and everyone knows those structures have held up very well. And anyone that's been to those areas would you can see the testament to that. But yeah, I don't know if you've got any other thoughts on that, but it's a product that is becoming wider and more awareness around it now, colloidal silica. You do have to be careful with it, as we've learned in our past from good and bad experiences, is different colloidal silicas have quite different results. Are they stabilized? What's their reactive times? What's the size of the particles? What are they stabilized with? You can be well off course very easy with colloidal silica, can't you? But it's a very good result when it's right.
Yes, that is a point. It depends on the process of producing them as to whether they've been built up or reduced as to the actual particle size, and smaller is better. But they are extremely reactive. That's how they work, of course. They're not to be confused with a silicate, which is actually a stable, non-reactive molecule. So I suppose in the context of dealing with them in the batching plant, they've got a number of advantages, don't they? They're very safe and fairly compact for how much you need to achieve the result. Is that right?
That's good. And there'll be a lot of listeners out there that would have experience with colloidal silicas and with a lot of different admixtures and inclusions for concrete. But one of the big things actually, Brendan, is there's a lot of powdered admixtures out there, silica fume, microsilica, etc., those terminologies. And one of the big concerns that we're seeing through the industry now is purely comes down to the quality control of adding powdered admixtures. How do we actually know? 2 a.m. you got this mass pour, you got trucks, logistics everywhere. The drivers are responsible to know what's in their load. The batching guys doing their job. Are we actually backing up and entering our powdered admixtures, etc., in the right process, in the right amounts, the right dosage rates for that mix, etc. So one of the beauties of colloidal silica is their ability to, because it's liquid and very easy to move, is to literally just pump in our processes with the batching plant. So you can dial it up. It becomes part of a mixed design. It's in a tank like a lot of your other admixtures, your supers, etc., and it becomes part of that process. So that's one of them. It's very easy to have in holding tanks. It doesn't have a shelf life. If you keep it moving, etc., it lasts for a long time. You can keep it in the tank. You can just dial it up on your systems and your software. And exactly what you say. It's not a huge requirement, and we're only talking in most mixes less than like 3 litres per cubic metre of product. So it's very easy to include, relatively low cost in comparison, and a very good result for what it does.
And just the other thing which comes top of mind in many cases is, would you like to say a word about the sustainability of the silica that we're sourcing?
Yeah, safety is a big thing as well, isn't it? What products are we dealing with? Is it safe to handle? Is it if you got skin, or if you happen to drink some, etc., what does it do? But that's where sustainability kicks in. There's sustainability of the concrete itself, which everyone's trying to obviously lower that footprint. And the beauty of what we're doing with colloidal silica, I guess, is being able to source it very sustainably from geothermal extracts, actually, and then stabilize it through processes sustainably. And then so we can come out with a very low. So a lot of our pretty much all our products actually have got the EPDs now, which comes out with our GWT or global warming potential ratings, etc., and numbers, and we come out with very low figures on those, which is brilliant for this versus a lot of products that are produced in factories using high heat, etc., a lot of energy to produce, transported for long distances, those sort of things, and they build up to not really reducing the footprint like we should be.
Yeah, that's interesting. Something that is a strong point in many situations, particularly with concrete, as we're looking to reduce that footprint, as we've already said. That's great, Hayden. Really appreciate you joining me today. And to all our listeners, thank you very much. Feel free to have a browse around on our Invisible Strength media site. There's a lot of material there. And we look forward to having you in the next segment of this series.
Thank you. Cheers.
Markham, adding life to concrete.